Good day, grade 11 students. Welcome once again to our general mathematics class. So in our previous discussions, we tackled about inverse functions and the exponential functions. So today, we will tackle about the inverse of an exponential functions. Okay, and it is called logarithmic functions. So here are the objectives for this lesson. So you must be able to represent real-life situations using logarithmic functions, distinguish logarithmic function, logarithmic equation, and logarithmic inequality. Solve logarithmic equations and inequalities. Represent a logarithmic function through its table of values, graph, and equation. Find the domain and range of a logarithmic function. Determine the intercepts, zeros, and asymptotes of logarithmic functions. And lastly, solve problems involving logarithmic functions, equations, and inequalities. So let us have first the definitions of terms. So the logarithmic function with base b defined by f of x is equal to logarithm of x with the base b is the inverse function of the exponential function with base b whose value is always positive. That is, y is equal to logarithm of x with the base b if and only if x is equal to b raised to the y power, for b is greater than 0, and b should not be equal to 1, and x should be greater than 0. Okay, so as you can see, from the logarithmic form to exponential form, so in our logarithmic form, y is equal to logarithm of x with the base b. Okay, so our base is b. Okay, and in our exponential function, the base is b. Okay, and from our logarithmic form, so y becomes the exponent. Okay, and it is equal to, so b raised to the y power is equal to x. So meaning from our logarithmic form, we can change it into exponential form and vice versa. From exponential form, we can also change it to logarithmic form. So as you can see, x and y values, okay, interchange. So in this case, okay, so the exponent y is equal to the logarithm of x with the base b. And take note that in both cases, whether it is on logarithmic form or in exponential form, so the base should be greater than 0 but not equal to 1. And x, okay, meaning the value, okay, x should be greater than 0. So meaning no negative values. Okay, since there is no negative value, if we raise, okay, the base b by an exponent of y, if b is greater than 0 and not equal to 1. So an equation that involves an expression such as logarithm of x with the base b is called a logarithmic equation. And an inequality of the form logarithm of x with the base b is greater than or equal to 0, or logarithm of x with the base b is less than or equal to 0, or any variation of this type is called a logarithmic inequality. We also have the terms common and natural logarithms. So common logarithms are logarithms with base 10. So logarithm of x is a short notation for logarithm of x with the base 10. So meaning, if there is no written base, let's say for example, we have logarithm of x. So it means that the base is equal to 10. Next is the natural logarithms. So natural logarithms are logarithms to the base e. And as what we have discussed in our previous discussion, so e, okay, the Euler's number is approximately equal to 2.71828. Okay, so in our natural logarithms, so base e are denoted by ln, ln or ln. So in other words, ln of x is another way of writing logarithm of x with the base e. Okay? So there are several properties of logarithms. If m, n, a, b, and c are positive numbers and a should not be equal to 1, b should not be equal to 1, then, so first property, logarithm of 1 with the base a is equal to 0. Okay? So, meaning logarithm of 1 with any base, okay, is equal to 0. Okay? Since any base raised to the 0 power is equal to 1. Next, number 2. Logarithm of a with the base a is equal to 1. Okay? So, if the base and the value of our value in our logarithm are the same, so it is equal to 1. Next, logarithm of 1 over a with the base a is equal to negative 1. Okay, since a raised to negative 1 is equal to 1 over a. Number 4, logarithm of a raised to the x power with the base a is equal to x. So, parang kinansel lang natin dito. Dalawang a. Okay? So, equal siya doon sa exponent na x. Next, number 5, a raised to logarithm of x with the base of a is also equal to x. Okay? Parang na-cancel out na lang din doon yung a natin. And number 6, logarithm of mn with the base a is equal to logarithm of m with the base a plus logarithm of n with the base a. So, it is just like in our laws of exponents. Okay? If you have the product, okay, according to the product rule, so, if you have the same base, you will add the exponents. So, here, if we, in our product rule, so you will add the logarithm. Okay? Yeah, so we have logarithm of m with the base a plus logarithm of n with the base a. So, by the way, another term for logarithm is exponent. Okay? Next, logarithm of m over n with the base a. So, it is the quotient rule. Okay? If you have the same base, and then you are dividing, so you will subtract the exponents. So, here, since it is logarithm, you will subtract the logarithms. So, we have logarithm of m with the base a minus logarithm of n with the base a. And number 8, we have logarithm of m raised to the c power with the base a is equal to c times the logarithm of m with the base a. Okay? Number 9, if logarithm of m with the base a is equal to logarithm of n with the base a, then m is equal to n. So, it is a 1-to-1 property. Okay? M is equal to n. You have the same base, same logarithm. Next, number 10, we have logarithm of m with the base a. It is equal to logarithm of m with the base b over logarithm of a with the base b. So, it is called change of base formula. So, from base a, it became base b. Okay? And then, you just divide. So, m and a. So, logarithm of m with the base b divided by logarithm of a with the base b. Next, if we have a raised to the x power, so it is equal to b raised to x times the logarithm of a with the base b. Okay. Next, number 11, logarithm of a with the base c. So it is equal to logarithm of a with the base b times logarithm of b with the base c. Number 12, logarithm of a with the base b times logarithm of b with the base a is equal to 1. 13, logarithm of x with the base 10. So it is equal to logarithm of x. Okay? And ln of x is equal to logarithm of x with the base e. So rewrite the following exponential equations in logarithmic form whenever possible. So letter A, 5 cubed is equal to 125. So if we will write it in logarithmic form, so we have logarithm of, okay, logarithm of 125 with the base of 5 is equal to the exponent, which is 3. Okay. Letter B, we have logarithm of 1 over 49 with the base of 7 is equal to the exponent, which is negative 2. Letter C, 10 squared is equal to 100. So we have logarithm of 100. Okay, with the base of 10 is equal to the exponent, which is 2. In letter D, we have logarithm of 4 over 9 with the base of 2/3 is equal to 2. Okay. In letter E, we have logarithm of 10,000 with the base of 0.1 is equal to negative 4. Letter F, 4 raised to 0 power is equal to 1. Okay. So we have logarithm of 1 with the base of 4 is equal to 0. Letter G, 7 raised to the b power is equal to 21. So we have logarithm of 21 with the base of 7 is equal to b. Letter H, e squared is equal to x. So we have logarithm of x with the base of e, okay, is equal to 2. Or since it is base e, so we can say that ln of x, okay, ln of x is equal to 2. And letter I, negative 2 squared is equal to 4. So cannot be written in logarithmic form since the base cannot be negative. Okay? The base should be greater than 0, not equal to 1. Next, write the following logarithmic equations in exponential form. So, yung kabaligtaran ng kanina. So, we have logarithm of m is equal to n. Okay? So, the base is 10. So, we have 10 raised to n is equal to m. Letter B, base is 3. So, we have 3 raised to 4 is equal to 81. Letter Z, logarithm of 5 with the base of square root of 5 is equal to 2. So, we have square root of 5 squared is equal to 5. Letter D, logarithm of 64 over 27 with the base of 3/4 is equal to negative 3. So, we have 3/4 raised to negative 3 is equal to 64 over 27. Letter E, logarithm of 2 with the base of 4 is equal to 1/2. So, we have 4 raised to 1/2 is equal to 2. Letter F, logarithm of 0.001 is equal to negative 3. So it is equal to the base of 10 raised to negative 3 is equal to 0.001. Letter G, ln of 8 is equal to A. So we have ln of 8. So meaning base E. So we have E raised to A is equal to 8. Okay? Next. Find the value of the following logarithmic expressions. So letter A, logarithm of 32 with the base of 2. Okay? So we will find for the logarithmic expressions. So we have y is equal to logarithm of 32 with the base of 2. So let us rewrite it in exponential form. So we have base 2 raised to y is equal to 32. Okay? Now 32 can be written as 2 raised to the 5th power. And according to 1-to-1 property, so we can say that the exponents are equal. So y is equal to 5. Therefore, logarithm of 32 with the base of 2 is equal to 5. Next, letter B. Y is equal to logarithm of 729 with the base of 9. So we have 9 raised to y is equal to 729. Then, change 729 in an expression wherein the base is 9. We have 9y is equal to 9 cubed. So 1-to-1 property will say that the exponents are equal, so we have y is equal to 3. So therefore, logarithm of 729 with the base of 9 is equal to 3. Next, letter C, logarithm of 0.001. Okay, so we have y is equal to logarithm of 0.001. Okay, so base is 10. So we have 10 raised to y is equal to 0.001. Okay, then let us rewrite 0.001 in an expression having 10 as the base. So 10y is equal to 10 raised to negative 3. Then we can say that y is equal to negative 3. Okay, so therefore logarithm of 0.001 is equal to negative 3. Next, letter D. Logarithm of 16 raised to 1/2. Logarithm of 16 rather with the base of 1/2. Okay, so we have base of 1/2 raised to y is equal to 16. Okay, then let us change 16 into an expression having 1/2 as the base. So we have 2 raised to 4, then 2 becomes 1/2, so we have 1/2 raised to negative 4. So positive 4 becomes negative 4. Okay, and since we have the same base, which is 1/2, so we can say that the y now is equal to negative 4. That's why negative 4 is the answer of logarithm of 16 with a base of 1/2. Next, letter E, logarithm of 1 with a base of 7. So it is equal to 0 according to the first property. Okay? And letter F, logarithm of 5 with a base of 5. So we can write it as 5 raised to y is equal to 5. So we have now y is equal to 1. So logarithm of 5 with the base of 5 is equal to 1. Next, logarithmic equations and inequalities. So steps in solving logarithmic equations. Write all logarithmic equations on one side of the equation and the constants on the other side. Where 2, use the properties of logarithms to rewrite the logarithmic expression as a single logarithmic expression. 3, use the definition of logarithm to rewrite the expression in exponential form. 4, simplify the exponential expressions and solve for the variable. And number 5, check your answer by substituting it into the original equation. Exclude from the solution any logarithm of a negative number. Such value is called extraneous solution. Okay? So, example, solve for the value of x in each logarithmic equation. Letter A, logarithm of quantity 5x plus 7 with the base of 4 minus logarithm of quantity x minus 3 with the base of 4 is equal to 2. So, we can write this as a single logarithm. Okay. So, we have here logarithm of quantity x plus 5 plus the logarithm of x minus 2. So, it is letter B pala. So, letter B. So, we need to solve letter A and letter B. So, letter A muna tayo. So, we have logarithm of 5x plus 7 with the base of 4 minus logarithm of quantity x minus 3 with the base of 4 is equal to 2. Medyo antok na ako. Madaling araw na. Anyway, tuloy natin. So, we have here, we need to make this as a single fraction. Kasi logarithm of 4 parehas. Base 4. So, we have 5x plus 7, x minus 3, then subtraction. So, in making it as a single fraction, we can have quotient. So, we have logarithm of 5x plus 7 divided by x minus 3 with the base of 4 is equal to 2. Okay? So, we have now a single logarithm. Kasi dito dalawa pa siya. Logarithm of 4 tapos logarithm 4 ulit. So, dalawa, pinag-isa natin. Okay? Next. We have 5x plus 7 over x minus 3 is equal to 4 squared. So, changing logarithmic to exponential form. Okay? Next. It is equal to 16. Okay? 4 squared is equal to 16. And then, applying cross multiplication, we have 5x plus 7 is equal to 16 times the quantity of x minus 3, which is equal to 16x minus 48. Okay? And then, you can now combine like terms. So, we have here 5x minus 16x is equal to negative 48 plus 7. Or we have 7 plus 48 is equal to 16x minus 5x. Okay? Then 16x minus 5x is 11x is equal to 48 plus 7 is 55. And divide both sides by 11, so x is equal to 5. Okay? Now, in checking, if x is equal to 5, we have logarithm of 4, so we have 5 times 5 plus 7, minus logarithm of 5 minus 3 with the base of 4 is equal to 2. So, we have here 25 plus 7, so 32. Okay, dito 5 minus 3 is 2. Okay. Then, gawing single fraction, logarithm of 32 over 2 with the base of 4 is equal to 2. 32 divided by 2 is 16. So, logarithm of 16 with the base of 4 is equal to 2. And, logarithm of 16 with the base of 4 is really equal to 2. So, it is true. Therefore, we can say that the value of x here is equal to 5. Okay? Next, letter B, logarithm of quantity x plus 5 plus logarithm of quantity x minus 2 is equal to logarithm of quantity x minus 2. So, let us make this as a single fraction. Okay. So, logarithm of x plus 5 is quantity of x minus 2 is equal to logarithm of x minus 2. Ginawa na natin single fraction yan. Addition, so naging product dito. Okay? Next, we have quantity x plus 5 is quantity x minus 2 is equal to x minus 2. 1-to-1 property. Paras na logarithm with the base of 10. Okay? Then, multiply quantity x plus 5 plus quantity of x minus 2. So, we have x squared plus 3x minus 10 is equal to x minus 2. Okay? Then, we have x squared plus 3x minus 10 plus 2 is equal to 0. So, we have x squared plus 2x minus 8 is equal to 0. Then, get the factor. So, quantity x plus 4 is quantity of x minus 2 is equal to 0. We can say that x here is equal to negative 4 and x is equal to positive 2. Okay. So, let us check if x is negative 4 and 2. So, try muna natin sa negative 4. So, we have negative 4 plus 5, then negative 4 minus 2, and negative 4 minus 2. So, logarithm of 1 plus logarithm of negative 6, logarithm of negative 6. Okay. Kapag 2 naman, di 2 plus 5 plus 2 minus 2. Okay. So, dito kita na natin. Kasi, dito pa lang sa taas may negative 6 na, negative 6. So, hindi pwede yon. Negative yung value natin doon. Dito, ganun din. Nagkaroon tayo ng logarithm of 0. Ay, dapat yan ay greater than 0 dapat siya. Okay? So, undefined na dito. Not defined na yung logarithm natin. So, meaning no solution. Okay? Kasi logarithm of negative 6, bawal yan. Hindi pwede mag-negative yan. Logarithm of 0. So, bawal din. Kasi dapat ay greater than 0. Okay? So, no solution. Next. Steps in solving logarithmic inequalities. So, represent the inequality in standard form. Determine the zeros of f of x. Find the domain restriction and the intervals to consider. Solve for the test value of x. Write the solution of the inequality. And take note, if the logarithmic inequality is of the form f of x greater than 0 or f of x is greater than or equal to 0, then all of the intervals with the positive sign are solutions. But if the logarithmic inequality is of the form f of x is less than 0 or f of x is less than or equal to 0, then all of the intervals with the negative sign are solutions. Let us have these examples. To show the answer na. So, we have here, find the solution for x in each logarithmic inequality. So, letter A, logarithm of quantity 2x plus 5 is less than logarithm of quantity 3x minus 1. Okay? So, subtract both sides by logarithm of 3x minus 1. So, we have logarithm of quantity 2x plus 5 minus logarithm of quantity 3x minus 1 is less than 0. Okay? Now, sabi nga kanina sa pangalawa ay determine the zeros. So, in order for us to determine the zero, let us equate the logarithm to 0. And naging equal dito, equal to 0. Then, minus yan, same na base 10. So, pag isahin, single fraction. So, we have logarithm of quantity 2x plus 5 divided by quantity of 3x minus 1 is equal to 0. Okay? Then, applying cross multiplication. So, we can say that 2x plus 5 over 3x minus 1. Wait, change muna pala into exponential form. So, base 10 raised to the 0 power. And 10 raised to the 0 power is equal to 1. Then, applying cross multiplication. So, we have 2x plus 5 is equal to 3x minus 1. Okay? Then, add 1 on both sides. Okay? And subtract 2x on both sides. So, we have 5 plus 1 is equal to 3x minus 2x. So, we have x now is equal to 6. Okay. So, meaning mag-0 itong logarithm natin. Okay. kapag ang x ay equal to 6. So, here we have next step natin, determine natin yung restriction ng domain. So, dito 2x plus 5. So, restriction natin dito, we have negative 5 over 2. So, meaning x should be greater than negative 5 over 2. Okay, dito. Kasi yun yung dito, 0. Then dito, we have negative 1, so we have positive 1 over 3. So, meaning x should be greater than negative 5 over 2 and x should also be greater than 1/3. Okay? Kasi kung equal yun doon, so magiging 0 yon. Logarithm of 0. So, di po pwede. Dapat kasi positive. So, kaya greater than negative 5 over 2 and greater than 1/3. So, the domain restriction is x is greater than 1/3 since sa ating number line, so, diba, negative 5 over 2 yung isa 1/3. So, ang intersection ng dalawang yan ay nasa x is greater than 1/3. Kaya yung magiging intervals na i-consider natin, so we have x is greater than 1/3 but less than 6. Kinuha yung 6, dun sa na-solve natin na x is equal to 6. So, we have here 1/3, 6. And yung isa pa na interval, x is greater than 6. So, yung isa, 6 equal to 6 yan. So, isa less than 6, yung isa greater than 6. Okay? Or 6, positive infinity. Next step natin, create na tayong table of values. A table of signs. So, we have here 1/3, so x greater than 1/3 but less than 6. Yung isa, x is greater than 6. So, let us get a test value for x. So, of course, dito sa x is greater than 1/3 but less than 6, mas madaling gamitin ng 1. Then, dito, x is greater than 6, so we have 7. Then, get the value of f of x. Okay, get the value of f of x. So, paano kukunin yan? Ang ating f of x. So, isosolve lang. Logarithm of 2 times 1 plus 5 is less than. Say, logarithm of 3 times 1, okay, minus 1. So, we have 0.544. So, positive. But if x is greater than 6, example ay 7, so logarithm of 2 times 7 plus 5 is a logarithm of 3 times 7 minus 1. So, we have negative 0.022. So, sabi natin kanina, kapag yung nandito ay less than, kagaya yan, less than, okay, so ang gagamitin natin, yung negative ang kukunin natin dyan. Okay, so negative ang kukunin. So, pag nakuha na natin yung negative, so meaning the solution to the inequality is x is greater than 6. Okay? Next. Logarithm of quantity x plus 7 minus 1 is greater than logarithm of x minus 2. So, gagawin ulit natin yon. 0 yung sa kabila. Kaya, logarithm of quantity x plus 7 minus logarithm of quantity x minus 2 minus 1 is greater than 0. Okay? And then, equate na natin sa 0. So, magiging equal to 0 lang yan. Then, gawin natin single logarithm. So, we have logarithm of x plus 7 divided by x minus 2, the base of 10. So, equal to, so we just add 1 on both sides. So, equal to 1. Then, yan, magiging single logarithm na siya. So, logarithm of quantity x plus 7 divided by quantity of x minus 2 is equal to 1. Then, change into exponential form. So, x plus 7 over x minus 2 is equal to 10. Raise to the first power. Applying cross multiplication natin dito. So, we have 10x minus 20 yon, equal to x plus 7. Then, subtract 10 on both sides. Or pagsamahin sa kabila yung lahat ng may x, kabila naman yung constant. So, we have 10x minus x is equal to 20 plus 7. So, we have 9x is equal to 27. And x is equal to 3. Okay? So, the function f of x is defined when x is greater than, dito we have negative 7. And x is greater than 2. Kasi x minus 2 yun. So, x is greater than negative 7, x is greater than 2. So, dun yun magpapanama sa x is greater than 2. Kaya yun yung domain restriction natin. So, the intervals to consider, x is greater than 2 but less than 3. Okay? Ang isa naman, x is greater than 3. So, kuha tayong test value dito. So, example 2.5, sa kabila ay 4. And substitute dun sa given logarithm natin. Okay? So, using calculator, makuha 1.279. Kapag naman x is greater than 3, negative 0.260. So, ang sign, we have positive and negative. Since greater than, dito tayo sa positive. Meaning, x is greater than 2 but less than 3. Okay? So, that's how you solve for logarithmic inequalities. Next, the sub-application of logarithm in real life. So, earthquake magnitude on a Richter scale, the magnitude R of an earthquake is given by R is equal to 2/3 times logarithm of E over 10 raised to 4.40 with the base of 10, where E is expressed in joules. This is the energy released by the earthquake, and the quantity 10 raised to 4.40 in joules is the energy released by a very small reference earthquake. So, suppose that an earthquake released approximately 10 raised to the 12 power joules of energy. What is its magnitude on a Richter scale? Let it be, how much more energy does this earthquake release than the reference earthquake? Okay? So, solution, since E is equal to 10 raised to the 12 power, then R is equal to 2/3 times logarithm of 10 raised to the 12 power over 10 raised to 4.40. So, 2/3 now times the logarithm of, so 10 raised to 12 over 10 raised to 4.40 is 10 raised to 7.6. And logarithm of 10 raised to 7.6 is equal to 7.6. Thus, R is equal to 2/3 times 7.6 is equal to 5.1. So, this earthquake releases 10 raised to 12 over 10 raised to 4.40. So, meaning 10 raised to 7.6 or 39,810,717 times more energy than the reference earthquake. Next, the sound intensity. In acoustics, the decibel level of a sound is D is equal to 10 times logarithm of 1 over 10 raised to negative 12 to the base of 10, where I is the sound intensity in watts per square meters. So, the decibel level of sound in a quiet office is 10 raised to negative 6 watts per meter squared. What is the corresponding sound intensity in decibels? And how much more intense is the sound than the least audible sound a human can hear? For our solution, so our D, we have the formula is equal to 10 times logarithm of 10 raised to negative 6 over 10 raised to negative 12. And this is equal to 10 times the logarithm of 10 raised to 6. Since negative 6 minus negative 12 is equal to negative 6 plus 12. So, 6. So, by definition, logarithm of 10 raised to 6 is equal to 6. Okay? Thus, D is equal to 10 times 6 is equal to 60 decibels. So, this sound is 10 raised to negative 6 over 10 raised to negative 10 raised to 6 equal to 1 million times more intense than the least audible sound a human can hear. Okay, next, acidity and the pH scale. So, the pH level of a water-based solution is defined as pH is equal to negative logarithm of bracket function of H positive, where H positive is the concentration of hydrogen ions in moles per liter. Solutions with a pH of 7 are defined neutral. Those with pH less than 7 are acidic, and those with pH greater than 7 are basic. So, a liter solution contains 0.00001 moles of hydrogen ions. Find its pH level. Solution sense. Ang ating solution. Since there are 0.00001 moles of hydrogen ions in 1 liter, then the concentration of hydrogen ions is 10 raised to negative 5 moles per liter. Okay? The pH level is negative logarithm of 10 raised to negative 5. Since logarithm of 10 raised to negative 5 is the exponent by which 10 must be raised to obtain 10 raised to negative 5. Kaya yung logarithm of 10 raised to negative 5 is equal to negative 5. Okay? So, meaning yung pH is equal to negative logarithm of 10 raised to negative 5. So, we have negative times negative 5 is equal to 5. So, pwede mag-negative kasi ang A natin dito. Yan, negative. Sabi nga, pag same ang base nitong same din, may exponent na negative 5, pwede makancel yung base doon at yung 10 na nandun. Negative 5 na siya. Kaya, negative times the negative 5 equal to positive 5. Since positive 5 yan, ano ngayon siya? Acidic ba? Basic? Neutral. So, ano siya sa tatlo? Sabi kanina, kapag less than 7, kasi 5 yun acidic siya. Okay? Kaya yan, acidic yan. Next, graph of logarithmic functions. So, graph of f of x is equal to a times logarithm of quantity x minus c with the base of b plus d. So, tandaan na yung format na yan. A, B, C, D. So, the value of b, quantity b is greater than 0 or b is greater than 0 but less than 1 determines whether the graph is increasing or decreasing. Para sa exponential, ang base magdedetermine. Pag ang base natin ay positive number greater than 0, less than 1, increasing siya. Okay? Pero pag ang base natin ay less than 1, ang base is greater than 0, less than 1, decreasing. Pero pag ang base natin is greater than 0, increasing. Next, the value of A determines the stretch or shrinking of the graph. Kaya nga, vertical stretching at vertical, anong meron doon? Shrinking. Further, if A is negative, there is a reflection of the graph about the x-axis. So, reflection, yun pa rin. Reflection, stretching, and shrinking. Excuse me. Horizontal and vertical shifting. So, based on y is equal to a times logarithm of x with the base b, the vertical shift is d units up if d is greater than 0 or d units down if d is less than 0. Nandito, may plus d sa taas. So, kapag yan ay positive, so, ang d natin greater than 0. So, pag greater than 0 yan, mag-move ang graph natin d units upward. Okay? Pero pag negative yan, d units downward naman. At yung quantity x minus c na nandun, so horizontal shifting ang tawag doon. So kapag ang c ay positive, so mag-move to the right. Kapag ang c ay kapag ang c ay negative, so less than 0, to the left ang movement. Okay, so number 1, f of x is equal to logarithm of x minus 1. Logarithm of x lang to. Logarithm of x with a base of 3. Then, saka pa lang yung minus 1. Okay? So, ang negative 1 natin dito is d. So, pag d yan, vertical yan, di ba? Vertical ano siya? Negative 1. So, vertical shifting, magmumove ang ating mga points, yung ating graph, magmumove ng 1 unit, ano siya? Since siya ay vertical shifting. So, 1 unit downward ang i-move niyan. So, expressed in basic exponential form. Tok na ako So, ang basic form natin kasi dyan, ang base ay 3. Okay? So, y is equal to logarithm of x with the base of 3. Kaya yun, x is equal to 3 raised to the y power. So, yun yung basic exponential form. Yan yung gagamitin natin para masolve mamaya yung x. Then, make a table values, choose values for y, and solve for the corresponding values of x. So, dito sa table values natin, una muna ay kinuha natin yung y. So, ang y natin, mula sa logarithm of x with the base of 3, mag-a-assign ka, halimbawa, 0, 1, 2. Yun yung value ng y natin. Okay? So, kung 0, 1, 2 yun, kunin natin yung x. Using formula, x is equal to 3 raised to the y power. So, 3 raised to 0 is 1. Then, 3 raised to 1 is 3. And 3 squared is equal to 9. Yun yung x. Since meron ngang minus 1 doon, meaning vertical shifting ang magaganap, so magkakaroon ka ngayon ng new y. Okay? So, meaning yung y mo, magma-minus ka ng 1. 0 minus 1 is negative 1. 1 minus 1 is 0 and 2 minus 1 is 1. Ito niya yung new y natin. Kaya mayroon tayong ordered pair na x 1, y is negative 1. X is 3, y is 0, and x is 9, y is 1. Okay? So, ang domain natin dito, so, x says that x is greater than 0. Kasi yun nga yun, logarithm of x with a base of 3. So, x mo doon, pag nakit pa sa 0, is equal to 0. Kaya, x should be greater than 0 kasi hindi nga pwedeng basta-basta lang maging 0 yung nandun. Dapat positive. Kaya, greater than 0. Domain. At sa exponential, di ba, tandaan nyo naman, ang range natin doon, y is greater than 0. So, since ang range nun magiging domain, yan. Nasa domain siya, x is greater than 0. Ang domain natin sa exponential, all real numbers. So, dito, pupunta siya sa range, all real numbers. Okay? Ang x-intercept natin, value ng x, if y is 0, so ang y ay 0, x ay 3. Kaya nandun siya sa 3, 0. Okay? And then, ang y-intercept natin, so none. Okay? Kasi ang x natin, hindi magiging equal to 0 ang value niya. Bawal. Kaya yan, none. Then, zeros natin, ang x-intercept, kaparehas niya lang, so 3. Vertical asymptote natin, so mula doon sa domain, x is greater than 0, restriction natin, so x is equal to 0. And then, sa horizontal asymptote, since all real numbers yan, so no horizontal asymptote. Okay? And last, pwede na ako matulog. So, f of x is equal to logarithm of quantity x minus 3 with the base of 2. So, ang pinaka-basic exponential form nito ay base 2 raised to exponent na y is equal to x pa rin. So, gawa tayo ng table of values. So, ang ating logarithm of x with the base of 2, yun yung y natin. So, 0, 1, 2 ang iset natin. Then, kunin natin yung x using yung formula 2 raised to the y power. 2 raised to 0 is 1, 2 raised to the first power is 2, 2 squared is 4. And then, since x minus ito, ang c natin ay positive 3. So, kung positive 3 yan, meaning magmumove to the right 3 units. Kaya, yung x naman yung mababago dito. Okay? So, kung 3 yun, di plus 3 ka. 1 plus 3 is 4. 2 plus 3 is 5. And 4 plus 3 is 7. Okay? So, domain x is greater than 3. Kasi dito yon, restriction natin dito. Bawal mag-0 yan. Magsi-0 yan kung x ay 3. Okay? Kaya dapat greater than 3 ang x natin. Ang range, laging ang all real numbers. Ang x-intercept nito, value ng x, if y is 0. Okay? So, if y is 0, ang x natin, 4. Doon tayo titingin sa new x. Okay? Kaya 4 ang x-intercept. Ang y-intercept natin dito, okay, ay none. Wala tayong y-intercept kasi nga hindi value ng y yan if x is 0, hindi nga mag-0 ang x. Kaya none yan. Zeros natin, so 0 is 4. And vertical asymptote natin, yan. Vertical asymptote. X is greater than 3, so therefore x is equal to 3 ang ating vertical asymptote. Okay? So, in closing, sabi dito sa Jeremiah 29:11, "For I know the plans I have for you, declares the Lord. Plans to prosper you and not to harm you. Plans to give you hope and a future." So, that's all for today. So, I hope that you learn a lot from this video lesson. So, goodbye and God bless, grade 11 students.